Okay, as promised, I said I was going to work a few of these problems, practice problems with you. And we'll do that. We're not going to dwell on some of the easier ones very long. We know we've got two inductors in parallel. We can do product over sum or reciprocal. So I'm going to take, and notice they're both millihenries. So I'm dealing with like units. I'm going to take 30 reciprocal plus 35 reciprocal equals, take the reciprocal of that. And I come up with 16.15, which rounds to 16.2. So easy enough. All right. Total inductance of this one. Now, we first have to figure out the total and total inductance here. So we can do product over sum. We can do reciprocal. 21 reciprocal plus 15 reciprocal equals, and the reciprocal of that. So my inductance here, total inductance, and we'll write this on the page here, is, let me find my pen, and there we are. So LT, that shouldn't be L sub T, I need to undo that. So bear with me a moment. LT equals 8.75 millihenries. So now that I have LT, I can calculate my ZT. Actually, it's looking just for the total inductance. So yeah, getting ahead of myself. So still pretty easy here. We're still just only applying the inductance formula here because it did not ask us for inductive reactance. So just inductance. So here it is, 8.75. So I'm getting a little ahead of myself there. So clear the screen. Total inductance here, same thing, except we got 3 this time. This is why I love the reciprocal formulas. I can do all 3 with product over sum. I would have to do the first 2, get their equivalent value, then put that up with the third. Here I can just reciprocate each one and get the sum of that, reciprocate that answer, and I'm done. So let's do, and notice they're all millihenry. So let's do 10 reciprocal plus 21 reciprocal plus 15 reciprocal equals, and let's reciprocate that. 4.67, so here we go. Easy enough. So now we're getting into the inductive reactance of this circuit. So this is going to be a multi-step process, simply because we have to take care of a couple of different things. So let's first get these two inductors. Now I know they're separated by a resistor, but this supply doesn't know that. It just knows there's some inductors out there. It's going to react to them. The order has no bearing. So I'm going to take 0.1 and reciprocate that, plus 0.3, reciprocate that, and then get the reciprocal. So my X of L here, sorry, I said X of L. My L total is what I meant to say, not my X of L. So we'll write it correctly. L total equals 0.3 millihenries. Wait a minute, that can't be right, I don't think, because we're coming up with the same answer. So I forgot to do something. So that'll happen. That's okay. Instructors make mistakes too. So let's go back and try that one more time. Something didn't take. So let's go back to our calculator. Let's clear it. We've got a 0.1 and a 0.3. So I'm going to say 0.1 reciprocal plus 0.3 reciprocal equals, and then I'm going to reciprocate that. That looks potentially better because it should be lower than our lowest one, just like when we do resistors. So I'm on board with that potentially being our right answer more so than what we had a while ago. Something didn't look right about that, simply because we were equal to our highest value rather than our lowest. So L total equals 0.075 millihenries. So we know R total. That's easy enough. It's 20K because there's only one resistor. If there were more than one, we'd have to do the same thing with resistors, product over sum or reciprocal. So let's take a look at what we've got to do. We've got to apply the formula for ZT, first of all, to get our total. Actually, we've got to get the X of L first. So let's solve for X of L here. And it is 2 pi FL. And this is X of L total. So I'm going to write total here. And then we're going to get our overall, dadgummit. It's looking for inductive reactance, and it's looking for the total inductive reactance. So yeah, we're going around the right path. Thought I got my cart before the horse again. So this is 2 pi FL. So we're going to say, let's come over here and clear our calculator. Clear 2 times 3.14, 2 pi, times frequency is 10K. And we're in K, we're in millis. We don't have to worry about that cancel. So I'm going to say times 10 times 0.075. So that matches. So the total inductive reactance is 4.71 ohms here. We already see that answer is there. That's what we're looking for. So since this, I thought we were having to go a little deeper, I want to re-explain that. The very first thing, it wanted total inductive reactance. And again, inductive meaning just the inductors. And it wanted inductive reactance, which is X of L total. So first we had to arrive at our XL total, our L total, Then take that L total and apply it using 2 pi FL to get our X of L total. And that is the 4.7 ohms. I'm about to clear the screen, so if you need to back up, just let you know. So we'll answer 4.7 ohms, and hopefully we're right. Yes, we are. So again, it's easy to, 1, skip something, and 2, to maybe perhaps go a little deeper than you're meaning to, simply because when you're used to these complex problems, the easier ones seem easier by and large. So just be careful when you're doing this. Okay, so this is another inductive reactance one. And we do have 2 coils, a single resistor. And notice we're also in base units here, which is good. We have Henrys and Hertz, which means when we do our formulas, there will be no conversions because of mixed units. So that's a good thing. So the very first thing we need to do is get our L total. So we've got to get L total. And again, that's just going to be a matter of applying the reciprocal formula. And again, that should be less than 75 Henrys, or we made a mistake just like I did earlier in the session. So let's do 100 reciprocal plus 75 reciprocal equals, and reciprocate that, 42.86 will round. So 42.86 millihenries. Henrys, not millihenries. So used to hearing millihenries. So let's undo that, and let's just do pure out Henrys. And that seems to be the right answer because it is less than our lowest. And that's pretty much a correct proportion. So I think we got the right answer there. So we've got to, looking just for inductive reactance here. We're not looking for Z total, which will come later, I'm sure. So we've got to 2 pi FL, this 42.86. So I'm going to come over to my calculator, and we're going to say 2 times 3.14, which is pi, times frequency, which is just 60 hertz, times 42.86 equals. And that is 16,149. The decimal point is way over there. And notice all our answers are in K. So if I want to convert this to K, I've got to move that decimal 1, 2, 3 places. So 16.149 easily rounds to 16.2. So it looks like our XL total equals 16.2K. My point is hard to see. So there's 16.2 k ohms. So we're going to choose that, see if we're right. And there we go. So again, pretty easy, not too much depth. But now we're still asking for total inductive reactance. So again, this is going to be one that's just a couple of steps for us. So the very first thing we got to do is we've got to solve between L1, L2, L3. Notice all three of these are in millihenries. I can go ahead and tell you L total, we'll do it on the calculator. But if I've got three inductors of the same value, their overall value is going to be 1/3 of the value. And that only works if they're all the same value. So if there were two of them, it'd be half. If there were three of them, it'd be a third. If there were four of them, there'd be a quarter. But this is easy, but let's actually process that. It's just a nice little math trick, if you know it. So we're going to say 33 reciprocal plus 33, whoops, one too many threes, reciprocal, plus 33, still one too many threes, reciprocal, equals, and we're going to reciprocate that. And no surprise, 11 millihenries. So we arrived at the same answer we did because we knew the little math trick. So nothing too hard about that. So now we have to 2 pi FL this value here. So let's do that calculation. 2 times 3.14 times frequency is 33 kilohertz. We're in millihenries times 33 times 11. Whoops, one too many ones. Equals 2,279 ohms. We know that decimal point is right here. If we move it over to get K, 1, 2, 3, 2.2 K, which rounds to 2.3. So X L total equals 2.3 K ohms. And there's our answer right here. So let's click on that. And we are correct. So let's begin the next problem. Okay, I went ahead and put up a couple of formulas here because we're almost out of video time and I wanted to get this one knocked out. And that's our X of L formula and our ZT formula. So we only have a single resistor and a single inductor here. So we got to solve X of L to get the ohmic value of this inductor. So let's do that first. I'm going to come over to our calculator. I'm going to say 2 times pi 3.14 times, and notice we're talking about a frequency of 33K and an L1 of 33 millihenries, so K in millihenries offset. So I'm going to say times 33 times 33 equals. So we'll round that to 6.84, might as well say. So X of L is equal to, and I'll use a different color, 6.84 K ohms. Well, our R total is easy. It's 33 K ohms. So I'm going to write this value up here. We're going to go ahead and apply this. So we're going to say 33 times 6.84, and both of these are in K, so I'm not writing units. And we're going to square both of those. 33 squared plus 6.84 squared. And we'll do the top and bottom math separately. And we've got about a minute left. I hope we can finish this. In fact, I'm going to pause the video, get those values, and then we'll talk about them. Okay, I think we can finish this. I came up with 33 times 6.84 is 226. Square of 33 plus the square of 6.84 added together, and taking the square root is 33.7. So we're going to say 226, which is what these numbers are over here, divided by 33.7, and this will be in ohms, comes up with 6.7, and this is in K because we began all with K. Remember that, K and K. So our answer is 6.7, and that's about all for this video. We'll go on to the next one. We're going to make sure that answer is right, and I'll see you in the next problem. Thanks.